Thanks to everybody on the call today for joining the NuScale Robotics ATC joint presentation on the Q-Span Metrology Measurement Kit. Pleasure to be joined today by Stefan Frederick from NuScale Robotics. He'll be presenting with us today. And just wanted to give everyone just a quick background on us as ATC, and then I'm going to kick it over to Stefan to go through the presentation. My name is Chad Whited. I am a Director for New Business Development for our Midwest region for Advanced Technologies Consultants. ATC, we are for short, has been in business since 1964, started in Southeast Michigan. Since 1989, when our current president joined his father with ATC, we've expanded now into 23 states. And as the majority of those 23 states, we represent the Universal Robots collaborative line of robot arms. And I have it over my shoulder here. We've been with UR for almost 2 years now, and it's a fantastic product. It's the #1 collaborative robot in industry today. They own about a 50% market share globally. They're growing exponentially in the educational market because of their UR Plus partnerships, their integration with companies such as NuScale, and their curriculum and content. And ATC, we've had the pleasure, like I said, of representing them for a couple of years. We, as part of that partnership, were able to expand our offering with using an application kit that Stefan is going to present here from NuScale Robotics as this transitions into more metrology measurement. And we start going beyond just teaching the basic robots and teaching applications such as machine tending or welding or any type of application you'd find out in industry. So again, we welcome everybody in today. We will be recording. We'll follow up. Please type questions into the chat. And from here, I'm going to kick it over to you, Stefan. And again, we certainly appreciate you being here.
Yeah, thanks for the introductions, Chad. Special thanks to you and your team at ATC for hosting NuScale Robotics on this presentation. So again, I'm Stefan from NuScale Robotics. I'm based out of our facility in Victor, New York, which is right outside of Rochester, which is between Buffalo and Syracuse, New York. I support the sales and marketing team for NuScale, and I work closely with manufacturers as well as distributors like ATC to expand our robotics offerings into the educational market with the goal to help educators teach students how to bring together and use a lot of different types of technologies related to robotics, part handling, as well as metrology automation. So today we'll talk about collaborative robots, why they're important within the manufacturing industry, and why the use of cobots and quality inspection is a growing area of importance for manufacturers. Talk about how employees can add value to their company by adding quality control directly to the production floor, as well as the benefits of automating offline inspection within a quality lab. I have a bunch of application examples and videos that we'll review throughout the presentation. We'll also discuss the new curriculum and training programs that are now available to help teach students about robotics and how they can gain robotic skills to make them more employable and more valuable to their employer. We'll also walk through a live demo towards the end. And then, as Chad mentioned, we'll close out with a Q&A. So a little bit about us. NuScale Robotics is a division of NuScale Technologies. We have over 18 years of experience and numerous patents in micromotor and motion control systems development. We have a strong background supporting universities and education customers with our motion systems, historically in robotics, mechatronics, mechanical engineering, as well as neuroscience programs and research labs. NuScale Robotics leverages our company's motion control expertise to design and manufacture reliable, high-precision end-of-arm tooling and application kits to enable automated dimensional inspection with cobots. We're really experts at merging metrology with collaborative robots, and we're actually the only UR Plus partner that has a UR Plus certified application kit for quality inspection. And we're the only partner that's developed curriculum for automated metrology. We're also a certified systems integrator for Universal Robots, again, with our core specialty being in automating metrology. Overall, all the products that we make are usually featuring extreme miniaturization, ease of use, and most importantly, plug and play simplicity. Little about collaborative automation. So really the future manufacturing jobs that we're going to see will require automation skills and collaborative robots being used as tools that bring these skills to every employee and empower them to use them on the production floor. Our CEO typically says, you know, when you come to work now, you expect to get a laptop or a computer to do your job. And in the future, I think we'll see, you know, employees coming to their new job and saying, where's my robot? You know, and have that expectation right up front. So automation, you know, is a really great way to run a business more efficiently, reduce costs, and help manufacturers maximize output and just stay competitive within the global economy. And historically, automation's really only been accessible to large manufacturers with vast resources, you know, that could afford to pay systems integrators to come in with teams of automation engineers and integrate this, you know, fairly expensive capital equipment. Collaborative robots, though, you'll hear us referring to them as cobots, are industrial robots that help empower these smaller and medium-sized manufacturers automate higher mix and smaller batch production jobs. Cobots are really designed specifically to be used around human operators, and optimal robotics applications are often described as dull, dirty, and dangerous jobs. And they're really ideal for automation because they can quickly reduce injuries and repetitive strain and help keep staff engaged on more interesting tasks within the facility while reducing costs for the manufacturer. And as Chad mentioned, UR is the market leader in the cobot space. They've sold over 50,000 robots throughout the world, and they're really rapidly growing and expanding in popularity. One of the reasons for this is because they're very easy to program and they're quick to deploy for operators of really almost any skill level. I often describe this robot as being about as easy to use as your smartphone. And it's really important to note you do not need to be an engineer to learn about how to use this robot and how to program it. The program that we're running today, you know, my background is strictly sales and marketing, but I'm able to program this and redeploy it. You know, so again, cobots are really tools that bring automation skills to every employee. And part of the driver for this is, and one of the reasons UR is such a leader in the marketplace, is the adoption of third-party plug-and-play components. And these really allow companies to spend a lot less money and time on engineering in each automation project and get into production faster. So third-party companies like NewScale Robotics, we offer apps for the UR Cobot, and that allows manufacturers to use automation tools and the robot all within one touchscreen interface called the Teach Pendant. And we'll get into that with the demo later on so you can see what all that looks like. So cobots can be deployed, repurposed, and redeployed much more easily than traditional industrial robots. And you know, I'll be frequently mentioning high mix, small batch production. That's really where UR lives. They can be redeployed very easily to multiple different applications. It could be doing welding one day, it could be doing metrology the next day, machine tending the next day. And with their enhanced safety features, most applications can operate near people without any safety guarding. And that, you know, that would be after you do a proper risk assessment. And this is especially beneficial for smaller companies that are space limited. They can't put up guarding. You know, guarding and safety sensors and all that are an additional expense if you have to include them. So it just makes these types of automation systems much more approachable. Small and, you know, I think an important thing to keep in mind is small and medium-sized companies are most likely where students will end up post-graduation. And these businesses are really the ones benefiting from collaborative robots because of the lower barrier of entry that are, you know, you experience from the ease of use, the training programs that Universal Robots has developed, and the wide range of these plug and play tools that are available for the UR robot that let you do more things with that robot and spend less time redeploying it for other things. Ultimately, we're trying to empower these non-engineers like machine operators or technicians to use automation as a daily tool and help them add value to their employer by increasing throughput and reducing production errors and lowering costs within manufacturing. So, many manufacturers that we speak with really tend to lump quality control, which is a critical business function in manufacturing, especially. They tend to lump it into overhead costs, and it's really not often considered a starting point for automation, which is pretty surprising because QC is full of these expensive, labor-intensive, manual, boring, and repetitive tasks that are really great candidates for automation. Inspectors and especially CMM programmers are often paid much higher than many other production staff. So, while manual inspection tools are really great for quickly checking dimensions in reference to a drawing, they're really prone to error over time, especially human error. Operators could get repetitive stress injuries and ultimately turnover because employees just don't really want to sit around at a bench doing this all day long. So Cobots overall, we're empowering QC teams to automate manual part gauging and caliper measurements. And our goal, kind of like what you're seeing in the video, was to enable QC automation at about roughly the same speed as a human operator, take up the same amount of space that a person would need to manually inspect parts at a bench, and overall eliminate these data collection errors you can get from person to person doing inspection. So really trying to free employees and inspectors up to do more productive QC tasks, such as more intricate and complicated inspections, maybe something like CMM programming. So Q-Span Workstation is what you see on screen. It's also on this webcam streaming the demo we're playing. I'll go through the specific components later on, but the main idea here is we're able to not just pick and place parts like what you get from a gripper, but we're actually able to pick the parts, measure dimensions. We are recording the data, and then we're also placing the parts into an output location. So grippers repeatability is about 2 times better than most digital calipers. But again, as the manufacturer, you're also getting all of the benefits of removing that human to human variation that you get from having maybe it's 3 different operators inspecting the same part throughout a day. So what are some typical inspection processes in a production environment, and where would this system be applicable? Why is it an important thing to learn about? So every manufacturer really needs a quality department if they're trying to do any sort of improvements, because if you can't measure a process, you can't improve it. So that's why the QC department is so necessary. And often the best manufacturers and the best employees embed quality improvements into every business decision and manufacturing process, which is really why it's so critical that students understand this early in their careers. So traditionally, when we're inspecting and collecting dimensions on parts, you have kind of 2 primary methods that you see in most production facilities. So the first is you're inspecting parts on the floor with manual tools, recording data manually or with a direct connection to a software program. It's a nice way to quickly check a dimension to verify your inspect. But if you're using these tools for hours on end, again, you're prone to human error or employee turnover. These measurements for manual tools, or maybe forgetful operators who accidentally allow the machine to run for prolonged periods of time without making measurements or process adjustments, can also lead to failing batches of junk parts that would need to be reworked or scrapped entirely, and both of which are unnecessary expenses for the employer. So, the other option is you might end up with some good parts that are rejected, some bad parts that ship to a customer, or you just don't have enough data captured to help the company continuously improve their processes. So it's really one of the most critical tasks to automate if your goal is to have a fully automated cell. especially one that can run lights out and can continuously produce good parts without having to have an operator, babysit the cell or tend to the QC functions of the machine throughout a day. So the other common method 2, would be parts are brought into the metrology lab and they're measured on more advanced inspection equipment. Maybe you have a CMM or a vision system that an operator would need to load parts in and out of. Maybe it's an optical comparator. It's a really good way to measure more complex geometrical tolerances using more advanced equipment that really exceed the capabilities of the gauges and calipers you're using on the floor. So usually this is kind of a semi-automated inspection. The operator does have to load parts in and out. And that's really a time sink for the quality labs. They don't want to pay someone to just sit there and load parts in and out of these machines all day. So this is another area where you can alleviate those higher paid CMM programmers from having to do these types of jobs on a day-to-day basis. And it's really not the most effective use of a quality person's time to load parts in and out, especially where manufacturers are facing a labor crisis and there's a lot of open positions for skilled manufacturing staff, especially quality inspectors. So both methods 1 and 2, can really be extremely boring and monotonous if an inspector has to do this all day long. And so we're really trying to help these QC teams automate this type of material handling and inspection tasks. So we'll run through a few specific application examples here. So one high level thing to think about here is, cobots are helping us bring gauging closer in time and location to the production process. So this allows you to measure in the QC lab with real-time data sharing, gauge parts near the machine, and combine it with machine tending. So periodically inspecting the dimensions on parts to verify that they're being produced within tolerance helps machinists determine whether the process is performing correctly. And this dimensional inspection can reliably provide insights into process changes. And I would bet that most of your educational programs that teach machining, sorry, wasp is flying in my face. I bet that, most of the educational programs that teach machining have some sort of required section or separate courses on metrology, because it's really important for those machinists to understand, because it's the most critical function that they can use in terms of controlling any production process throughout that cycle. So one of the reasons that it's useful for the machinist to understand is because if the tolerances start to drift on a part, if the dimensions start to drift, and it might be that a piece of tooling has started to wear, meaning it might need to be replaced, or you may need to set a new offset within the machine or swap out the machine tool. Again, if you don't do this and you're just simply doing machine tending, pulling parts in and out, you can end up with these runs of bad parts that you have to scrap, you can't use, or you have to spend a ton of time reworking. So this demo here, we're machine tending this Herco machine. We actually pull the part out and we're inspecting the outside diameter. You can see there that that operator, we just swapped in a 3D printed part as an example here. We measured the outside diameter. It was determined that that was a failing part, which it would be in that case, and then it moves it off to the side and fails it. In maybe like a plastic setting, like injection molding, this same type of process might occur on molded parts to inspect critical dimensions to help us make sure that our molds are producing good parts. So here's an application with our customer OptiPro Systems using a UR3E cobot with a precision gripper caliper to inspect the dimensions on a large stack of cord lens blanks. So this production involves these stacks of laminated glass that are bored out, and they produce several batches of these cores at one time. So that requires that an input tray is loaded into the Cobot inspection workstation, which is different than the single part feed we saw in the previous application. And using a tray like this lets you load the tray, hit play, and then walk away from the inspection system. That operator can go do something more productive. and keep adding value to their employer by letting this robot do these types of monotonous tasks and help you control the process. So, the flexibility of the collaborative robot really allows us to load many different part types onto the one workstation and inspect these high mixes of parts. So the next cycle, we might throw in a different stack of lens cores that are larger diameter, or you might throw in some square lenses. You could do all sorts of different parts in there as long as you play the appropriate inspection program on the UR robot. So this is actually from the same customer, OptiPro Systems. So we have the Q-Span workstation on this mobile workstation, and we're rolling it into the metrology lab. And we speak with many manufacturers that are dedicating more inspection work to their QC labs to meet the industry's growing demand for stricter QC requirements, more data, and more complicated dimensions and manufacturing processes to make these parts. So putting more parts into the QC lab, that can often lead to bottlenecks in QC labs. And that's a really unnecessary, often unnecessary and expensive way to inspect your parts. So there's really a big opportunity here for cost reduction in the QC lab and freeing up that bottleneck. So I would consider this kind of more of a non-traditional cobot application. There's no parts being fabricated by the machine we're working with, but we're gaining value by freeing up your CMM programmer from having to sit in front of the machine, load the parts in and out all day long. And it's a really, again, that's a really expensive function of this metrology task to pay an inspector to do, especially when you're paying them $25 to $30 per hour. So, I won't spend more time on this, but if anyone's interested, there is a full case study on our website if you want to take a look at that. The one other thing I forgot to mention, though, is one important function here is, maybe you do have to load all the parts into the CMM, but we can actually pre-measure and pre-inspect the parts. So you're really maximizing the value of the robot in this situation as the manufacturer. You're able to pick the part, pre-inspect it, and if you say, hey, this part's out of tolerance already, you don't have to waste those 5 minutes loading the part into the CMM and having to run through your normal CMM procedure. This video shows how a cobot can automate air gauge measurements. So air gauges are an older technology that we've been working to automate and kind of get into the Industry 4.0 era. They're extremely accurate and reliable pieces of technology for making fast part measurements with micro-inch precision. And many manufacturers that are in industries like aerospace, automotive, some medical customers, more than likely have several of these or a few of these throughout their facility. So they generally require that a part is loaded with very tight clearance onto this air gauge mandrel. And, just like the CMM from the previous slide, this type of task can be automated with collaborative robots. NuScale Robotics, we specialize in doing this type of automation, extracting the data from that older technology, the air gauge, and helping tie it all in as one fully automated tool that the customer can use and redeploy for a lot of different things. So how does all this relate to the industry trends we're seeing in manufacturing? A lot of these, the three that I have here are all really interrelated and important to think about, especially as we try to prepare students to get into manufacturing. So first big trend is the labor crisis and lack of available labor in manufacturing. I'm sure that a lot of you see firsthand that there's fewer and fewer people getting into the manufacturing world. There's a lot of manufacturers I speak with that have experienced the impact from the labor crisis and challenges associated with both attracting and retaining their staff. And for many manufacturers, this has really been compounded by the COVID pandemic. And a lot of them, I would say the majority cite this as their number one business priority as they move forward for the next several years. So there's a lot of data on these trends, and with an aging workforce, manufacturers are also losing a really large knowledge base as skilled employees with 40 plus years of experience are retiring faster than new people are entering the workforce. So with less staff and a desire to grow the business, owners and management teams are putting a lot more pressure onto existing and new staff to increase output, but with less human capital. So how do you do that? Automation is certainly one solution to help employees meet these more challenging production and performance demands while also improving the business. And labor is really often the biggest cost for a quality department. And why is that? It's a good question to ask, but it's really because quality is a critical function in an organization, and you need these skilled and highly trained operators to help you do the job well. Most QC processes are also manual, and that leads to a lot of high overhead costs. I think overall, new hires that are trained in automation can really help solve these problems for their employer, and really help their company remain competitive in the global economy. Another industry trend we're seeing is the desire to collect more data. This is going to be a requirement of a lot of new employees to the workforce. You got to collect data, you got to write it down, it's got to be accurate. It's interesting though, because as we get into Industry 4.0 and everyone's talking about, data. There was a recent article I read in in Quality Magazine from Infinity QS. They spoke with 260 manufacturers and found that 75% of those surveyed were still collecting data manually, and 47% actually still relied on pencil and paper, which was kind of an interesting statistic considering the direction that we hear about the industry moving in. Data and data integrity is especially important in regulated industries. So using robotics to help you automatically record and store the data should help you not just improve the accuracy of data collection, but also reduce the likelihood that data is being falsified, and help you avoid non-conforming inspection ratings by your customers. So new employees that are skilled in this and understand the importance really add a lot of value to their company, help their business retain more sales opportunities, more accounts, keep production volumes up. It's definitely a critical thing that every employee needs to think about. Third trend that I see frequently is really the desire for easy to use automation and quality control technologies. While automation is seen as a really good way to fulfill the skilled labor gap, it's also seen as a way to attract and retain workers that you're hiring. Employees want to feel and see that their employers are on the cutting edge of technology and using that technology to their advantage. And it shows employees and their customers that their company is really working to improve its business with this new technology and has strategically positioned itself to succeed in the market with those technologies. So as new workers get into manufacturing, it's really important for them to understand automation, why it's important, how it can benefit the business, and the value that it can bring to the manufacturing setting that they're working in, so that these employers that they're working for can remain competitive. We are also seeing some trends towards integration of safe for human technologies like cobots. There's also autonomous mobile robots and smart conveyors that are starting to be adopted in factories, and to keep workers safe, and especially important nowadays, socially distanced. We're also seeing a lot of bottlenecks identified in quality departments, especially within metrology labs. And most companies, particularly those with limited automation experience, want to see what we're calling the application of automation, as well as inspection systems, meaning that these technologies have to be easier to use, learn, teach, and adapt, just like the apps we use on our smartphone every day. So Universal Robots and strategic partners like NewScale, Robotics, we've worked to be on the cutting edge of easy to use automation and software applications to help these companies deploy and adopt automation technology sooner. And, it's especially important for aiding in these often overlooked aspects of the production process, like quality control. So, how does this, what can we do in the EDU space? So robotics curriculum is now becoming available for both Universal Robots and the Q-Span Workstation Kit. NewScale Robotics has a introductory program called Introduction to Metrology. So these packages provide students with accredited training in certain topics using specific equipment, and it gives students more skills to showcase when they're looking for employment, and really gives employers confidence that their new hires can become productive in their facility much sooner. So we really created this to provide training that students can use on the job very easily. And I think the fundamentals of the robot are important too. We talked about the UR+ ecosystem as well. So, understanding specific applications within your university setting certainly set you up to be able to use the other plug and play components that we're offering here in this UR+ ecosystem to deploy it for a lot more different types of applications. Maybe in the future they'll do packaging or welding or something like that. So overall, we're trying to help them also understand quality control tasks in industrial settings, kind of like all of the examples that I just showed you, and how those relate to the success of the company, the business, why quality is important. So really improving student skill sets with real world equipment and, opening them up to more job opportunities from having that type of experience. They're also gaining hands-on experience with the Universal Robot. And again, they're the world leader in collaborative automation. And, they'll learn how to set up, use, and adjust equipment. So we've developed a metrology curriculum package using this Q-Span Workstation Kit to really teach students the fundamentals of metrology, also known as the study of measurement, and robotic QC automation. So we're including the definition of units of measurement, validation of measurements, and traceability to align measurements to standards within the industry. And of course, the practical application of using collaborative robots to automate metrology tasks so that they feel confident to deploy the system for types of applications that we were showing earlier in the presentation. So as you're looking to implement the introduction to metrology and Q-Span Workstation Kit, it's important to have some experience with the Universal Robot. So whether you're using UR's online academy training simulator, you've completed their educational certification program, or you're just familiar with UR robots from using them in the lab, we do recommend that you have some experience with the UR robot before starting on our advanced metrology curriculum. UR also does offer a separate curriculum package specialized specifically in the UR robot, and we can combine both curriculums into one workstation if that's of interest. These curriculum packages also include trainings for instructors. We have instructor guides, PowerPoint decks to be used in the classroom. Those have embedded videos. We have embedded labs, quizzes, final exam, as well as a capstone team project. So you can kind of see on screen here how we break the curriculum down into 10 different modules to, not just give the students an introduction to robotics, but also the metrology concepts we've been talking about, and sort of the fundamentals of metrology, and give them hands-on experience with the robot and the Q-Span Workstation Kit. So we're going to switch over to the demo now. Chad, while I'm kind of switching my screen sharing, do we have any questions that have popped up in the meantime?
No, Stephen, I haven't seen any questions come into the chat as of yet.
Okay. So let me break down the components of the Q-Span Workstation Kit, and then I'll show you some kind of basics of programming, and then we can wrap up with any questions. If you guys think of any questions from the presentation or while I'm doing the demo, please feel free to put them in the chat, and then Chad can get them lined up as we close out here. So basic fundamentals of the Q-Span Workstation Kit. So fundamentally here, we have the Universal Robot. This is the UR3E robot, the smallest robot that Universal Robots has available. On the end of the arm here, we have the multi-tool mount. And so that allows us to mount 3 different grippers onto the end of the arm. And why is that? Why do we have 3? One reason is because we need to mount different fingertips to match the features of the parts that we're trying to inspect. You can see here we have a flat to a flat, so that might be used to measure something like an outside diameter. Here we have sapphire probe tips, similar to what you'd see in a metrology lab on something like a CMM, usually measuring something like inside diameters. 3 grippers also gives us more throughput and productivity in a manufacturing setting. Also included in the workstation, we have the robot mounted to the workstation table here. We do have these on caster wheels, so it is actually mobile. You can see I'm kind of moving it around. We did also show you that in the video. And then here we have different part trays available. This is where you would be able to just put your tray down, hit play, and then leave from your workstation, and the system would be up and running, inspecting parts in a production setting. So the idea here is you kind of have your modular tray configuration. You can come over, place the tray down, start your robot program, and leave. But first, obviously, we do need to set up an inspection program to get started. 2 other things I should mention. We have these gauge blocks and ring gauges. So these are used as the NIST traceable artifacts in the system. They basically act as a way to zero the grippers and set a reference and make sure that everything is accurately measuring and everything is repeatable and operating as it should be. So I'll talk a little bit more about that in just a second. And then the measurement nest here, we place the part onto this measurement nest to orient the part, make sure we're gripping it at the same location each time. It also offers a little more area for the Q-Span workstation to maneuver around and manipulate that part. So yeah, do we have any questions, Chad?
Really, the only question that came into the chat was actually one that I had answered, but then you answered as well. The machine comes with a sample setup of parts, correct?
Yep.
And then in that sample set of parts, there are some faulted parts in order to test that your calculations are correct and everything is working properly.
Yep. Yeah, that's correct. Yeah, so we include. I think I messed up the program when I reset the reference because it looks like it's failing a lot of these parts. But generally we would include probably 3 fail parts and then 9 passing parts, roughly, so that those parts are organized correctly between the pass and the fails in the demo cycle. And that was what we showed earlier. The demo cycle ran through the 12 parts that I started with as I was talking through the presentation. We ended up with 9 of these parts that ended up in the pass bin, and 3 that ended up in the failure. But yeah, this is included. This whole robot program that we're playing here is actually also included. You receive that. So the idea is you can get the system in, set up our example parts and example program, and immediately be able to play that, measure parts, handle the parts, record the data. And then you can kind of use that as a framework as you're learning about the system and the curriculum.
And I'll just ask a couple of questions here because I know they'll come up, Stefan. So you currently show this on a UR3.
Yep.
And if a customer currently has a UR3 and would like to turn that UR3 into this kit, is that possible?
Yeah, absolutely. So all you have to do is get the Q-Span workstation and then just mount the robot onto it and you're good to go. The controller in this system is actually located under the table. We have a mounting bracket that's located beneath the workstation tabletop here. So it's really a compact, tight system. You can wheel it between classrooms, different labs, whatever you need to do. Very mobile. You know, I bring this to demos on site at customers, rolling it through parking lots and all that. And so yeah, you can absolutely mount your UR3 on this. If you're inclined to use a 5 or a 10, you can certainly do that. We would just need to work with you probably to make a little bit of a bigger workstation, but generally we are usually operating on the UR3E.
Okay.
That is one important distinction, Chad, is this setup you see here will only work with E-series robots, which are the newer ones for anyone that's on the call that might be more of a legacy Universal Robots customer using the older style CB series.
Okay. Excellent. And as far as your curriculum and content, if a customer was to reach out to us and say, you know, I'm interested in the platform, you know, we would be able to show them any pricing that is associated with the certification. We as ATC also have somebody that if you are interested in doing some extensive training and would like to get a couple of days of training, we have someone that's on call that can come in and do that. Your ATC representatives would come in and actually set up and commission your equipment. And then we'd have an option to bring somebody in to do a little more advanced training, which is what we do with all of our products. But that is a feature that is a service that we provide.
Yep.
Okay.
Hey guys, I have to take off real quick, but I have a question.
Sure.
When you're running a cycle like this, will the cycle then go back to the gauge block, say every 50 measurements, and then determine if there's been a change, and then will it keep track of those changes over time, so you can actually look at the in a different column the checks to see if there's any run out in the system?
Yeah, you can absolutely set it up to do that. So that would just be we do have a function to automatically set the reference throughout an inspection program. So, you know, as you know, maybe it's every 15 parts, maybe it's every 50 parts, you know, whatever you want to do.
Yeah.
You can set that timer up to come down and reset all of those references from scratch. And you could start by, you know, measuring the part or measuring the artifact, the gauge block or the ring gauge. And if you're getting weird results, you know, you can keep track of that and and monitor that. So certainly if that fluctuation is happening, we would want to know about it, because it really shouldn't adjust very frequently unless you're operating in some really extreme environments, or there's, you know, residue building up on the fingers from from oils or coolants on a machine or something. You might be seeing that. So we do generally recommend you do that automatically and track that. So good question. Any other questions, anyone?
I'm just answering a couple that are coming into the chat, but I think we've fairly covered everything at this point. I'm just kind of going down through the list here.
Yeah, thanks again to the ATC team for having us. And yeah, we look forward to talking with you guys after the event.
Yeah, but again, as what they said, if you want a more in-depth look, if you want to bring more people on board to take a look at one of the systems, we can certainly set up a direct call with you and your team. If there's no other questions, everybody, enjoy the rest of your afternoon. We're 1 minute late, so we tried to get you out of here by 2, but everybody enjoy the rest of your afternoon.